Okay, well, God bless you wherever you are today. We're going to go over 5.7, which is solving quadratic inequalities. Let's go ahead and open up in prayer. Father in heaven, thank you for this day. I thank you for the students you've given me. I pray that you would help me to explain lesson 5.7, quadratic inequalities, in a way that's understandable to them, in a way that they can use it, understand it, retain it, and use it for your glory, however that may be. We give you praise. I ask that you bless my student this day. Help me to love them in the same way that Christ already does. In Jesus' name, amen. What are our objectives? Solve quadratic inequalities by using tables and graphs. Solve quadratic inequalities by using algebra. Only one new vocabulary term today, quadratic inequality in two variables. So, okay, when it comes to a quadratic inequality, we basically have four possible situations. Y is less than, y is greater than, y is less than or equal to, or y is greater than or equal to. And notice that the right-hand side of the inequality is in standard form. So when it comes to graphing quadratic inequalities, there's some basic principles you're going to use, and these are the basic principles. First, you graph the parabola that defines the boundary. If it's a greater than or equal to, or a less than or equal to, the boundary will be solid. Otherwise, if it's a less than or greater than, it will be a dashed boundary. And what that means is the boundary is not part of the solutions if it's dashed. Now for y greater than or greater than or equal to, you're going to shade above. I've got an error in my notes right here. This should be y greater than or equal to. For y less than or less than or equal to, you're going to shade below. And so what you're seeing here in this picture is the inequality graphed of y greater than or equal to x minus 1. Example 1, graphing quadratic inequalities in two variables. So we want to graph y is less than negative 2x squared minus 4x plus 6. Step 1, we graph the boundary of the parabola. It's got to be a dashed line because of the less than symbol. We know the y-intercept is 0, 6. We can find the vertex at negative 1, 8. And we know the x-intercepts are negative 3 and 1 by finding the zeros of the quadratic. This gives us the following picture. We shade below or inside, in this case, this parabola because of the less than sign. But let's say you're not sure where to shade. Let's say you don't see that yet. Well, you can choose a point not on the boundary. And so the easiest point to choose is 0, 0. Plug it back into the inequality and see if you get a true or a false statement. So what we did was we plugged 0, 0 back into the inequality. We get 0 is less than 6. That's a thumbs up. That's a yes. That's true. And what that means is that 0, 0 is inside the region to be shaded. So now we know where to shade. You can pause the video, try these on your own. I'm not going to give you the solutions now, but if you need help in class, I'll give you the solutions in class. Okay, what if you're solving a quadratic inequality in one variable, such as ax squared plus bx plus c less than or equal to 0, with an extra condition, a cannot be 0. Simply because if it were 0, you'd have a linear equation. You wouldn't have a quadratic anymore. Well, when you're solving a quadratic with one variable, or a quadratic inequality, the solutions are graphed on a number line. They're not going to be graphed in a parabola. They're going to be graphed on a number line. So this is how it works. Let's look at part A, example 2. We've got x squared minus 6x plus 8 less than or equal to 3. Subtract 3 from both sides to get 0 on the right-hand side. Now factor the left-hand side into x minus 1 times x minus 5. 1 and 5 are called the critical points because they would make the inequality 0. So I put 1 and 5 on a number line. I fill them in because this is less than or equal to 0, so that means that 1 and 5 are part of the solutions. I now have 3 regions of the number line to test. So I pick a number less than 1, I pick a number between 1 and 5, and I choose a number greater than 5, and I test that into the original inequality. And by testing it in the original inequality, I can figure out which regions are no, which regions will not be less than or equal to 0, and which region will be. So the solution to this problem is the interval notation, bracket 1, comma 5, close bracket. In set builder, it's the set of all x such that 1 is less than or equal to x is less than or equal to 5. Okay, what if I want to take the same problem but this time solve it by graphing? Well, I could take x squared minus 6x plus 8 less than or equal to 3. Using our calculator, we're going to make y1 equal to x squared minus 6x plus 8. We're going to make y2 equal to 3. And so what we're looking for is, where is y1 less than or equal to y2? When is the first y function below the second y function? And so if you look at the graph, you're going to see that it's below the line y equals 3 from 1 to 5 on the x-axis. And so again, the solution is the compound interval 1 less than or equal to x less than or equal to 5. Okay, here's another way to solve it. X squared minus 6x plus 8 greater than 3. Again, we already solved it using this first method to figure out where it's greater than, oh, excuse me, this is a different problem, I apologize. This one is x squared minus 6x plus 8 is greater than 3. Okay, the other one was less than or equal to. So let y1 excuse me, be x squared minus 6x plus 8. Let y2 equal 3. Now we're concerned about where y1 is larger or above y2. And so that would be here and here. And so those solutions on the real line go from negative infinity up to the number 1, but not including the number 1. Union 5, but not including the number 5, all the way to infinity. And we're going to use parentheses this time because we're dealing with a strictly greater than. And that means that positive 1 and 5 are not solutions to this inequality. Method 2, subtract 3 from both sides, and we get x squared minus 6x plus 5 greater than 0. Now we simply let y1 equal x squared minus 6x plus 5. And we want to figure out where it's above the x-axis. Graph the parabola, and we see that it's above the x-axis here and here. That gives us the exact same solution interval that we had before. Question, where is the graph above the x-axis? Well, from negative infinity to 1, union 5 to infinity. In set builder notation, that looks like this: the set of all x such that x is less than 1 or x is greater than 5. Go ahead and try these following inequalities on your own. You can pause the video, and if you need some help or the solutions, I'll give those to you in class. So, okay, each of the number line solutions we found in the previous example are divided into 3 distinct regions by the points 1 and 5. These points are called critical values. That's important. That should actually be in the vocabulary, to be honest with you. Critical values. By finding the critical values, you can solve quadratic inequalities algebraically. So let's talk about that. Let's solve the inequality x squared minus 4x plus 1 greater than 6. Step 1. We're going to temporarily transform our inequality into an equation. And we're going to solve by factoring. Subtract 6 from both sides. Then you get x squared minus 4x minus 5. factor the x squared minus 4x minus 5 into x plus 1 times x minus 5 and use the zero product property. We now have our two critical values, -1 and 5. Question: are those critical values part of the solution to the problem? No, they're not. Why? Because we're dealing with strictly greater than, not equal to. So we return to the inequality, and we now have three regions. 1, 2, 3. Choose any number you want from each region. Make them easy. So for example, the middle region, the easiest number is 0. The left region, -2. The right region, 6. We're going to test each of those regions by plugging them back into the inequality. So when I choose -2, I get 13 is greater than 6. That's a thumbs up. So that region is a solution. When I plug in 0, I get 1 is greater than 6. That's a thumbs down. So that part is not a solution. And when I plug in 6, I get 13 greater than 6. That's a thumbs up. That's part of the solution. So now I can shade those sections that were a thumbs up, part of the solution. So this goes from -infinity to -1, not including -1, united with 5, but not including 5, all the way to positive infinity. Go ahead and pause the video and try these on your own. Example 4, a business offers tours to the Amazon. The profit P that the company earns for X number of tourists can be modeled by P of X equals the following equation. How many people are needed for a profit of at least $5,000? Well, first let's understand the problem. We're investigating the number of tourists that can yield at least $5,000. So P of X is our profit function, and X is the number of tourists. So what we're investigating here is, where is P of X greater than or equal to 5,000? So we make that inequality. Subtract 5,000 from both sides. Divide everything by -25. Remember, when you divide an inequality by a negative, it changes, it flips the sign. So now we have x squared minus 40x plus 320 is less than or equal to 0. So I'm going to use the quadratic formula here in order to get the zeros, get the roots of this. I'm going to pretend it's an equation temporarily, just to get those critical points. So I get about 28.94 and 11.06. But you can't really have a decimal version of a tourist. So basically we're going to say 29 tourists or 11 tourists. So now I have three regions to check. I'm going to test each region by choosing a number within each of the regions. So I choose 10, 20, and 30. And it turns out that x equals 20 is the only number that works in this region, which means I need to have between 11 and 29, or in this case 28, because I can't have, let's go back up real quick. That says 28. So yeah, I shouldn't have said 29 because that's not quite 29 tourists. So I have to drop the decimal completely. So 28. I have to have between 12 and 28 tourists for this thing to work, for a profit of at least $5,000. Well, what if the business also offers educational tours to Patagonia, a region of South America that includes parts of Chile and Argentina? The profit P for X number of persons is the following equation. The trip will be rescheduled if the profit is less than $7,500. How many people must have signed up if the trip is rescheduled? So go ahead and pause the video and try that one. And that is the lesson. God bless you wherever you are today.